Hello, welcome everyone, everybody following online and stuff, and in the room, thank you for being here. Arnaud Ferraris started the Mobian project, so maybe us happy people can use the phone with Debian on it. Thank you so much. And he's actually today talking about what is going on for the next one, Trixie. It's coming soon. Thank you. Round of applause, please.
Thanks a lot. Thank you, everyone. So, hello, my name is Arnaud. Thank you for being here. I'm working for Collabora, and I've also been contributing to Debian for a bit over 4 years now, focusing mostly on making Debian work fine on mobile devices. So first, I'll start by introducing what we mean exactly by running Linux on mobile devices. Then I'll present the current teams and projects involved into using Debian on mobile devices. Next, we'll be detailing the current state of Debian on mobile and the recent improvements we've made and what we can expect for the next Debian stable release, which is Trixie, hopefully next year. And finally, a bit of a conclusion about what's coming on next. So first, what's this Linux on mobile thing? It's rather narrow in scope, because basically we're talking about not having any bit of Android involved here. It's really running a pure Linux user space with glibc or Muscle for the post-market OS folks, for example. But it's really being using only the software you have on your own desktop computers or laptops, and running that with a mainline kernel. Android vendor kernels are basically a nightmare. They are several years old, and they have millions lines of code added on top of mainline. This is something you can just manage as a volunteer project. So we're aiming for only mainline, or rather close to mainline kernels with only tens of thousands lines added. Why close to mainline? That's because hardware enablement is hard, and upstreaming patches to the Linux kernel is even harder. So we have to deal with a certain number of downstream patches. In terms of devices you can use for running Linux, there are a few devices that were meant to run Linux from the start. Those are built and sold by Pine64. You've probably heard of the PinePhone, PinePhone Pro, and all the PineTabs. You have also the Librem 5, which is sold by Purism using an XP chip. And for a few years, there's been people in the community working on supporting Android-first phones. So that includes, in terms of rather well-supported devices, that includes Snapdragon 845-based devices, so the OnePlus 6, 60, Pocophone F1, and Shift 6 MQ. And recently, there's been some interesting progress on enabling the Pixel 3a and its XL counterpart. They are using a Snapdragon 670, and it's sold, of course, downstream, but as I mentioned, a reasonable amount of patches. There's also work in progress on the Fairphone, starting with the version 3. And this is interesting because it's done mostly by Fairphone people. There was actually a conference here at Capitol du Libre last year, which I encourage you to go watch on YouTube or any video service you like. And there's, of course, a lot more. But those are the main devices we're talking about. It's a fairly limited number, but you have to start somewhere, right? We also have multiple graphical environments. So Fash, which is basically the mobile counterpart to GNOME, SXMO, which is more for Sway or iCube users, and Plasma Mobile for the KDE stuff. So you can still replicate the famous GNOME versus KDE flame war even on your mobile phone. Yeah. So how does it work in Debian? First, we have the DebianOnMobile team, which is just like any other Debian team packaging software for a specific field. And it provides official Debian packages in the sense that those are packages available from the main Debian archive. Those are the environments I just mentioned. You have also all the essential middleware, such as Modem Manager, which is quite useful on a phone, and other various services for MMS, haptic feedback management, and a few vendor-specific tools. We also maintain within this team a few applications which are either only or mostly useful for mobile devices. And one of our main area of thinking is finding Debian-compatible solutions to problems we only have in the mobile space. For example, Android devices are usually, at least the ones that you can run Linux on, are based on Qualcomm chips. And Qualcomm chips require a lot of binary firmware to work. And this firmware is signed by the phone vendor. So you cannot just use the firmware from the upstream Linux firmware repo. You have to use the one provided by the phone vendor. And you can find it on GitHub, but you don't have any license agreement attached to it, and so you don't have the rights to redistribute it on Debian. So we need to find solutions to this specific problem. There's also the issue that each device is very specific and has its own little quirks, and you have to manage device-specific tweaks using config files, config fragments, and this also has to be done in a smart way, I'd say, because otherwise you end up with one binary package for each device you support, and this obviously doesn't scale once you get past a few devices. So the DebianOnMobile team is working mostly on Salsa. I put the link to the Salsa group here. We also have a private ARM64 CI runner so that we can build packages for ARM64, as that's basically the architecture of pretty much all the devices we wish to run Linux on. This is actually really helpful and makes testing on devices way easier for people, saving us the build time of compiling big packages on devices with 4 slow ARM64 cores. So that's quite helpful. On the other hand, you have Mobian, which is the project I initiated in 2020. It's both a Debian derivative and a Debian team. The team itself is a subset of the DebianOnMobile team, and Mobian actually maintains a few packages which are in the main Debian archive. Those are, for example, the on-device installer we're using, the Plymouth theme, so you can have a nice logo and spinning wheel when you boot your device. But otherwise, our main duty is to maintain a separate package archive, which is hosted on separate servers, of course, with all the downstream packages we cannot yet upstream to Debian. I mentioned the kernel packages. There are too many patches, and those conflict with each other, so we can have them in Debian, and also all the device-specific tweaks and meta packages as well. For now, it's about 28 source packages, so really a small overlay on top of Debian, and we're aiming for less than 20 for the Trixie release. And finally, Mobian is also providing ready-to-flash images for all the devices we support, so you can easily test and install Debian, or at least Mobian, on your device. For maintaining this, we've put a lot of effort into the infrastructure itself and the use of CI. So I'd like to thank the Salsa CI team here, because they've been doing an awesome job creating easy-to-use pipeline. And we can also customize it quite easily. So basically, using Salsa CI, a few personal tweaks, and also our own runners for ARM64, RISC-V, and x86, we have scheduled pipeline that generates images on a weekly basis. Every day, there are pipelines running, checking for a new point release of each of our kernel packages, and then rebase them and publish the updated packages automatically. And all the building and uploading process is also automated. You just have to push a tag to Salsa, and then the build process will kick in, and the package will be automatically published. It's pretty much like tag to upload, which is being discussed in Debian right now, but much simpler and with a bit less security. But we don't have the same needs as Debian for Mobian. So where are we now, and what's happening in the next few months? For Bookworm, we already had quite a lot of generic packages not tied to any vendor or hardware device. Those were the graphical environment and middleware I mentioned earlier, but we didn't have lots of adaptive applications. They went mostly from the GNOME 43 version. Overall, the basic infrastructure was there, and it felt at least usable for the basics. We also have a few packages which are already in Bookworm targeting specific device. So the mobile Twix is one of them. It basically one single source package generating one binary package for each supported device, and those binary packages include the config fragments and tweaks you need to have the device properly supported. This works well because there are like 5 of them in Bookworm. As I mentioned earlier, it doesn't scale, so we have to rethink this part. The other important bit we had in Bookworm is Droid Juicer. This one is very important for Qualcomm-based devices because what it does is basically at boot time, it will mount the Android vendor partitions, fetch the firmware files from there, and import them to the Linux root file system. So that way we don't have to redistribute the firmware. We can directly grab what's already present on the device, and it can be used by the Linux kernel itself. So that's at least one problem we solved. Overall, Bookworm was a bit crude on mobile devices, but it was an important and major first step towards making Debian usable on smartphones. Now for Trixie, we've been improving a lot support for Qualcomm devices, mostly by packaging vendor-specific services. Basically, Qualcomm use specific protocols like QRTR or QMI to communicate with the various subsystems on the chip, the modem, the Wi-Fi, the DSP also. And so there's a couple more, hexagonal PC, which is used to communicate with the DSP using the faster PC protocol, which is, again, something pretty much specific to Qualcomm. But this enables sensors support, so you can have proximity sensors, accelerometer, and so on Qualcomm-based phones. There's also Q6 Voice D, which deals with the routing of audio during voice calls, so you can actually place phone calls on the phone, which is quite innovative. And finally, we've been also packaging a lot of new GNOME and Plasma Mobile applications, along with, of course, the GNOME team, the Rust team, and all the various teams involved in those environments. Plasma Mobile apps are currently blocked, waiting on the Plasma 6 transition, but it's coming. And hopefully Trixie will have a lot more adaptive applications and will be way more usable in the long run. And also there's a few Mobian packages now in Debian, but we still have some more work to do. So what's left before the Trixie release? What we hope to achieve in the next 2 or 3 months is to have a better per-device Twix management. The idea would be basically the same as what Droid Juicer essentially does, which is at boot time, identify the device we're running on, prepare all the config files and fragments that we need for this specific device, pack it all into a custom Debian package generated on the device itself and install this package. We could also just move the files around, but going through a Debian package makes it sure that DPKG, for example, is aware of the files we're putting here and there, and that if in case there is a conflict with another package, then DPKG can warn the user or give him the ability to fix this conflict. This service is going to call Twixtor. It's being worked on right now, and hopefully in the next few months we'll come up with actual results and probably in Debian package for dealing with this. We also need to drop the few remaining end-user applications we maintain in Mobian, which have a bunch of patches to be more usable on mobile devices, especially smartphones, as they have really small displays. The first one is Events. It has been forked upstream, and there's a GTK4 version which is called Papers. I've been handling the packaging for that one and plan to upload it to new next week, early next week, so that's another problem to be solved soon. And GNOME Text Editor, which is probably mobile friendly enough by now. We need still to run some tests to check how it is before dropping it from the Mobian repo. So overall, we made good progress, but even after this next release, we will have lots of work to do to improve usability on mobile devices. First one, it's mostly a personal wish list item. I want to make Mobian a Debian pure blend, which is basically meaning that all of the Mobian packages will be part of Debian, and we won't have a separate repo and infrastructure, except, of course, for the downstream kernels, which, for the reasons I mentioned earlier, cannot yet be accepted into Debian. We will keep also the image generation on the Mobian infra, but it's basically just CI, pipeline, runner, and a few scripts. Otherwise, we would need to enable also device support into the Debian kernel by first turning on the appropriate configuration options, but also ensuring the device support upstream is good enough. So that means improving the device support and, most of all, helping upstream the said patches. And finally, there's one big issue we are having in the mobile space. It's the voice call problem. Basically, 4 years ago, everyone was using Pulse Audio. And it was quite simple. Pulse Audio didn't care about mobile, didn't care about much in the end, except just running an audio server and being able to switch outputs and so on. But we came up with Call Audio D, which is a small daemon, acting basically as a session manager for Pulse Audio for the smartphone use case. The thing it does, it's basically unloads the Pulse Audio module, which does audio switching, and takes care of it all by itself, depending on whether it's in a voice call or not. The thing is, since then, we've all moved to Pipewire, and Pipewire is very, very nice. And one of the great benefits of it is that we get Wire Plumber, which is a full-feature session manager for the Pipewire stack. The problem is that Wire Plumber now clashes and conflicts with Call Audio D. They both try to make decisions about audio routing in parallel, but that don't have the same rules and the same goals. So what we plan to do is to basically turn Call Audio D into a proper Wire Plumber plugin with a corresponding set of rules, all of this being upstream, so that Wire Plumber has a specific use, a specific management of voice calls, and we can get rid of Call Audio D entirely. So to answer the title question, yeah, of course, we're not there yet, but we're definitely getting closer. And actually, with the Trixie release, Qualcomm devices will be able to use a vanilla 100% pure Debian user space. All you need to have would be a downstream kernel to have it work properly. But in terms of user space, nothing else outside Debian will be needed. That's already a great progress compared to Bookworm. And of course, for the fearless and the bravest, you can already daily drive such devices. As a matter of fact, my own personal phone is running Mobian. It's a Google Pixel 3a. And I definitely can live with it. So in the end, any help would be appreciated, be it on the hardware support front. We need lots of hands and brains to improve hardware support and, most of all, upstream the patches. There are also a few gaps to be filled in terms of applications and services. All the instant messaging stuff and so on, there are applications waiting to be packaged also. So yeah, feel free to join us. I've put a bunch of links here. The first one is where you will find those slides, so you can get back to it and review all of the links. And of course, links to the DebianOnMobile team, Mobian website and team, and all the communication channels we use for that. That's it for me, and I'm willing to take your questions.
I have a couple of questions. I understand that Google has been pushing Android device vendors towards using a common kernel and then implementing all their functionality as modules. Is that helping your task, or is that not?
Actually, the problem with Android is not so much the core kernel they're using, but the downstream patches the vendors will add on top of it. And the Google common kernel is mostly about the features of the kernel and which modules and features are enabled. We're mostly talking core kernel itself, not device drivers per se. And vendors are always free, even when using the Google common kernel, to add a pile of downstream device drivers which are in no way upstream compatible.
Okay, right. And the other thing was also sort of Android related. Has there been any work on integrating Waydroid so that where there isn't a native application available, users could potentially use an Android app?
Regarding Waydroid, so it's about basically running user space container of Android to use Android apps on Linux devices. I know there's an ITP for that one. I haven't checked the progress. I mean, that's obviously something that would be welcome. It would be probably in the contrib section of Debian, but I'm not sure it's being actively worked on right now, but it's part of the things we would welcome and help with.
I'm not sure I understood why you said that the kernels in use in Mobian couldn't land in Debian. I noted the number of patches. It was between 100 and 300, but Debian has been proposing the RT patch set for a long time, which is also, I think, a lot of patches. Do you think this is really what is preventing having this kind of kernels into Debian, or is there a deeper reason? Why couldn't you, patch a Debian kernel to create a directory with all of the patches you would need, instead of, I don't know how you do it right now, like having multiple source packages per kernel, per device? You could maybe put the configs and the patches in the main Debian kernel, and then I think that's all you need, right? Configs, patches, and then you would be good to go with the Debian kernel without having the need to go outside, and then you will have a full blend without having to export the kernels to somewhere else.
Yeah, you're right. There are actually two reasons for not importing patches into the Debian kernel. The first one is that quite a number of patches need maintenance. We don't want to put more burden on the kernel team. But the more important reason is that those patch sets conflict with each other. So you have patches for the Librem 5, for example, which touch the Cadence DisplayPort IP block. You have the same IP block used in the ROG chip SoC, the RK3399, so the PinePhone Pro, and it has other patches which are not compatible with the Librem 5 ones. Even on Qualcomm devices, you have multiple versions of a same driver, and so that will require at least having multiple binary packages, each with one specific patch set.
Exactly. You would have a kernel per device, that kernel Qualcomm, kernel something, which is something that could be possible. And nothing prevents you from having different directories with different patches that have been rebased differently. And everything could be in a single package instead of having it going everywhere, or like creating multiple kernel packages by hand. All of this could be in Debian. So I think it's not a real limitation technically. Maybe it's politically or something else, but it could be a directory with a list of patches for Qualcomm. Then you will create a Linux Qualcomm image or something to be discussed. Maybe.
Yeah, to be honest, that's pretty much what we're doing right now. We're only the source package is always pure upstream kernel, and we have all the patches as killed patches under specific folders for each device types. So yeah.
Thanks.
A question about your CI on Mobian. I think I've seen you have also CI for ARM64, RISC-V, and x86.
Yeah.
I'm curious about the two last. Is there a reason to build Mobian for RISC-V and x86? Do you support devices on those architectures?
So regarding RISC-V, we have no supported device for now, but we do hope that it will happen in the future. Actually, Pine64 have released the PineTab V, which is using a RISC-V chip. I've been playing with that and was able to boot it and have HDMI output with a few patches. So that one feels reachable. And regarding the x86 runner, it's mostly because we want to have full control of that one. And for example, the shared runner used on Salsa does not allow outgoing SSH connections. And we need that for our own CI. And also we need lots of resources. Image building goes through DebOS, and DebOS uses KVM, so it requires a higher level of privilege than what's allowed on the Salsa instance runner. This is why we have our own x86 runner as well.
Okay, thank you.
There's still a little bit less than 2 minutes.
Hi. Thank you for all your work. I have maybe a meta question. It took about 10 years for Debian that I was able to give my wife some laptop which user interface which was acceptable for her and had all the applications she needs. What do you think how many years it might need until she get a phone with all the applications like BarnUp, Flora Incognita or so, and user interface she would? I know you can't answer the question, but what is your guess about this?
It's really you need to be more specific about the needs. I mean, my personal use case is 100% covered with what we have currently in Debian.
Sure.
That's also because I don't need a mobile app to access my bank accounts. I can do it from a web browser. So that's eases things a lot. I also don't use WhatsApp. So
well,
that's
think
another
about
hurdle.
your mother. Please think about your mother. When do you think you could give your mother a mobile phone?
Never. Never, ever.
Okay. Good. Yeah, okay.
But yeah, maybe my mother was not the proper example. No, actually, I have really no idea. It mostly depends on interoperability of messaging systems and how we can access important services such as bank accounts. Some of it can work using Waydroid, for example, but banking apps will often not work because they require secure boot to be enabled with all the Google authentication and security module in place. So it really depends on how far we go from a legal perspective, reglementation perspective, into forcing the private actors to have open standards and be accessible from non-walled gardens, basically. And it's a much broader problem than just running Debian on a phone.
Thank you. Thank you, Arnaud.
Thank you
very
all.
much.